Hi, I've got a cold, so my voice is a little deeper than normal. Sorry about that. The current chapter focuses on statistical methods for determining the relative importance of each mediator in a set of mediators in an RET. It also discusses methods for whittling down the number of mediators in your model when you have a large number of mediator candidates. I begin by reviewing the major statistical techniques that have traditionally been used to assess the relative importance of mediators. For omnibus mediation effects, the primary focus is on the relative percent of the total variation or the relative percent of the total indirect effect that each mediator accounts for. I explain this technique in depth and I document why these approaches are unsatisfactory despite their popularity. For purposes of program evaluation, I argue that a focus on omnibus mediation effects often is misplaced. Consider two mediators in an outcome that are all measured on the same standardized metric, i.e. a mean of 0 and a standard deviation of 1. The path values and indirect mediational effect might be as follows. In this table, the mediators are listed as rows. This column is the path coefficient for the treatment to the mediator. This column is the path coefficient for the mediator to the outcome, and the indirect effect is the product of the two paths. Notice that each mediational chain suggests no mediation for the effect of the program on the outcome through the designated mediator because a link in the mediational chain is broken. A value of 0 in one link negates the other link no matter what value it has. Although both of the indirect effects signify the mediator in question is unimportant, the 0 indirect effect is qualitatively different in the two cases. For mediator 1, the 0 indirect effect is due to the program failing to create change in a relatively influential mediator. For mediator 2, the 0 indirect effect is due to the program targeting a mediator that has no causal influence on the outcome. How you as a program evaluator address the problem of a 0 or weak indirect effect would differ in the two cases, as I have discussed in previous chapters. For mediator 1, the problem lies not in the choice of the mediator that the program targets, but rather in the program's inability to change it. I need to revisit the program and figure out how to alter it in order to bring about change in the mediator. For mediator 2, the problem is not that the program fails to change the mediator, but rather in the choice of the target mediator per se. The program designers assumed the mediator is relevant to the outcome, but it turns out it is not. We need to move on from it and perhaps not focus program efforts on changing it. This is why I like to work at a per link level instead of the omnibus indirect effect value. I get a fuller sense of the operative dynamics. I first review methods for addressing the relative importance of the second link, namely the relative effects of mediators on outcomes. The methods I consider include an analysis of p-values, stepwise regression, lasso regression, generalized additive models, all possible regression approaches, the analysis of standardized path coefficients, and dominance analysis. I discuss the strengths and weaknesses of each approach. I next consider methods for determining which mediator has been most impacted by the treatment. Finally, I consider the case where you have a large number of plausible mediators, but that you must first enter into some form of data reduction to reduce them to a workable number for purposes of SEM analyses. This is the classic curse of dimensionality. Thanks.